Going on, guys, let's look at this problem right here. This question is asking, verify that the given functions form a fundamental set of solutions of the differential equation on the indicated interval form the general solution. Now here they have given the solutions. This is one of the solution and this is the another solution. Now we have to verify this is a solution. Now to verify this one, we take one by one. Like first, let's y1 is equal to e power minus 3x, and we take the first derivative and second derivative because we are going to plug it back in this equation and see whether we get 0. And if we get 0, it means this is a solution, right? And let's go ahead and try that one. Now if I take the derivative, first derivative of this one, that's going to give us negative 3 e power minus 3x. And if I take the second derivative, that's going to give us negative 9, actually positive 9, because negative 3 again multiplied by negative 3, that's going to be positive 9 times e power minus 3x. Okay, now we plug it back in this equation and see whether we get 0. Let's plug the first value. So first is y double prime, that is this one, 9 e power minus 3x minus y1 prime, that's going to be this one, minus minus, that's going to make this one plus, plus 3 e power minus 3x minus 12 times y. Y is e power minus 3x, e power minus 3x. Okay, that should be equal to 0. Now from this one you can see 9 plus 3, that's going to be positive 12 e power minus 3x. Here we have negative 12 e power minus 3x, so this cancels each other. From this one we can see this is 0 equal to 0, so this is a solution. So this one is a solution. Now we have to check this one is a solution. To find that one out, we have to take the derivative of this one again for this one. So this, let's say y2 is equal to e power 4x, and if I take the first derivative of this one, this is going to be 4 e power 4x, and if I take the second derivative of this one, this is going to be 16 e power 4x. Now let's plug it in this equation. This is going to be 16 e power 4x minus y prime, that's going to be 4 e power 4x, and then we have minus 12y, so minus 12 times e power 4x. This should be equal to 0. Now from this one you can see we have 16 e power 4x minus 4 e power 4x, that's going to be plus 12 e power 4x, plus 12 e power 4x minus 12 e power 4x, that's going to be 0. So it is, all of this cancels and we get 0 is equal to 0. So this is also a solution. Okay, this is also a solution. And the next thing is we have to verify this is a linearly independent. Now to do that we can use the Wronskian. Wronskian is we put y1 and y2 here. Let's say y1 is this one, e power minus 3x, and y2 is e power 4x, and here we are going to have the derivative on the bottom. The first derivative is minus 3 e power minus 3x, and here the first derivative of this one is going to be 4 e power 4x, and if you cross multiply AD minus BC, if you take the determinant, you shouldn't get 0, right? So if you don't get 0, that means this is linearly independent. That's what we want. Now let's see what we get. Here we are going to getting e power 4 e power 4x times e power minus 3x minus, and minus minus, this is going to make this one plus 3 e power minus 3x e power 4x, and from this one you can see this one is going to become, powers will add, so this is going to become e power x, 4 e power x. Now let's separate this one. So this is going to be 4 e power x, and here we are going to have 3 e power x. So totally we get 7 e power x. This is not equal to 0, so this is linearly independent. That's what we want. Therefore these two are solution for this differential equation. So we can write our final solution. Let's say by the superposition principle we can write this one as a complementary solution. So we can write this one as yc is equal to c1. The first solution is e power minus 3x plus c2 e power 4x. Okay, and this is going to be the complementary solution for this differential equation. I hope this helps. Thanks for watching.